Now, in this problem, we're told that the variable x denotes the sum of two distinct numbers selected randomly from our set of 1, 2, 3, 4, and 5. What we then want is to construct the entire probability distribution for the possible values of x. Well, since we have 5 possible outcomes, what we really want to do is to then choose 2 of those possible outcomes from our 5 possibilities. So 5 choose 2 gives us a value of 10 possibilities. Listing all of our possibilities, we could have a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5. We could have a 2 and a 3, a 2 and a 4, a 2 and a 5, 3 and 4, 3 and 5, or just 4 and 5 as our possible outcomes. If we then look at what our value for x will be from each one of these possibilities, we see that for getting a 1 and a 2, we actually have a sum of 1 plus 2, or 3. And likewise, for a 1, 3, we have a sum 1 plus 3, or 4. For a 1, 4, we have a sum of 5. For a 1, 5, a sum of 6. For a 2, 3, we have a sum of 5. For a 2, 4, a sum of 6. And for a 2, 5, a sum of 7. Likewise, for a 3, 4, we're going to have a sum of 7. For a 3, 5, a sum of 8. And for a 4, 5, we have a sum of 9. And so what this really tells us then, of our 10 possibilities, that for getting a 3, we have a probability that x is equal to 3 of 1, because it only occurs one time out of our 10, so we have a probability of 1/10. Likewise, for a 4, we have a probability that x is equal to 4 of 4 only occurs one time out of 10. For 5, we have a probability that 5 occurs now once twice. So our probability of 5 is 2 out of 10, or 0.2. For 6, we have a probability that how many times did 6 occur? Well, 6 occurs once and twice as well. So we have 2 out of 10, or 0.2. For 7, the probability that x is equal to 7 is given by 2 over 10, because 7 occurs twice there. And so we have a value of 0.2. For 8, we have a probability that x is equal to 8 of 1 time, so 1 out of 10, 0.1. And finally, for the probability of a 9, the probability that x is equal to 9, 9 only occurs 1 time out of 10, so again we have a probability of 0.1.